Hello everyone, welcome back to MacroLearning. We're still dealing with the alkanes part in the organic chemistry, and this is another question about the chlorination or the halogenation reactions of alkanes. Okay, let's see. Does the following product ratio contradict the order of stability of free radicals? Tertiary, secondary, and primary. Does this number contradict with this order here? So I think we're really being asked is that does this number contradict the order of reactivity of the different hydrogens on the alkane? Because the order of reactivity is equivalent to the stability of free radicals. Because the major step involved in the chlorination of alkanes is reaction of chlorine free radical with the alkane forming HCl as well as the corresponding Alq free radical. So what happens is the more stable this free radical is, the more reactive this alkane, this hydrogen is going to be, right? So the order of reactivity corresponds to the order of the stability of this guy. So the more stable the alkyl free radical is, more reactive. So the question can then be translated into, does these numbers, these product ratios, contradict the ratio, the order of reactivity of the different types of hydrogens, which is tertiary hydrogens is most reactive, followed by secondary, and primary is the least reactive. Well, I'm afraid that at first glance it might appear to be really contradicting with the order, because for one thing, if you look at this product here, it's going to be from the reaction of chlorine with this tertiary hydrogen, right? And this hydrogen is going to be more reactive than the other ones, than either primary ones or secondary ones. And that should give rise to the dominating product, right? It should produce the major product. But the fact is that this product only makes up 22% of the entire product. Only 22%. So the key here is that when we try to assess the relative reactivity of the different hydrogens from the product ratios, we don't want to just only look at the product ratios themselves. We have to include another thing, which is the number of hydrogens. That's the other thing that counts in the calculation or estimation of relative reactivity of the different types of hydrogens. So to see what I'm trying to say, let's draw out a full structure of that alkane, which is more like this. So let's now count the number of each type of hydrogen. So how many primary hydrogen do we have here? There's these three, and these three. So a total of 9 of them, right? And how many secondary hydrogens? Only these 2, correct? 2 of those. And what about tertiary hydrogens? Only 1. Only 1 of them. Okay. So the correct way to calculate the relative reactivity of the different hydrogens let's call it V, the relative reaction rate, if you will, of primary hydrogen to that of secondary to that of tertiary hydrogens equals what? We'll take into these numbers and put them in the denominators, you know. So we'll add up these two numbers, 16% plus 34%, because both account for the reaction product from the reaction of primary hydrogens with chlorine. And we will assume that these three hydrogens have very similar reactivity to these 6 hydrogens. So we will just add those two up, 34 plus 16%. Now divided by this number here, okay, to the secondary hydrogen, which is this, the product ratio 28%, that divided by this number 2, and that to tertiary hydrogen reaction product ratio, that's 22% divided by this number, which is 1. Okay, so let's do some real simple calculation here, and we'll just get rid of the percentage marks now, and so we get 50 over 9, that's about 5.5, okay, to about 14 exactly to 22. Now that's the correct ratio for relative reactivity for the different kinds of hydrogens. Now that we've taken into account these hydrogen numbers, we have made it a fair comparison again. Okay, if you look at only these numbers, it's not a fair comparison, because for one thing, the primary hydrogen is the least reactive. However, it was given 9 times more opportunity to react. 9 times more opportunity to react. So no wonder it gave rise to the leading products. 50% total primary halogenation product. Okay, so that's what the hydrogen numbers for each type of hydrogen. That's how it works when we try to evaluate the relative reactivity for the different hydrogens. So at first it appears that the ratio contradicts with the order of, reactivity of different hydrogens, but once we take into account the numbers, the hydrogen numbers, and use those in the calculation, in the correct calculation for the relative reactivity, we have got the correct numbers, correct ratios, which does agree this time with the supposed stability of free radical order, or as we mentioned, the order of reactivity of different types of hydrogens. So now these numbers do seem to make sense once we do the correct calculation. Alright, hope that makes sense to you too. But if you have any doubts or comments or questions, do not hesitate to drop me a line or give me a call, and please don't forget to subscribe to my channel or visit MacroLearning.com. Okay, thank you very much. I hope you enjoyed it. See you next time.